Hello and welcome to this video. As I had said that I will discuss roots of a quadratic equation in the next video. So here we are. So what are the roots of a quadratic equation? In general, suppose there is an equation in X. Then for the values of X for which the value of equation becomes 0 are called roots. So in this case, our equation is ax square plus bx plus c. So the values of x for which this becomes 0 will be called roots of this equation. They are also called the roots of the quadratic expression ax square plus bx plus c. Now for this equation to be a quadratic equation, a must not be 0. So how do we find out the roots of this equation? So that is very easy. We first multiply the entire equation with a so that it becomes a square x square plus abx plus ac is equal to 0. Now we can write it in the form of ax whole square plus 2 into ax into b by 2 plus b square by 4 plus ac minus b square by 4. The reason of writing this way is we try to make it something like a square plus b square plus 2ab. So the midterm is abx and the first term is ax. So we have 2ab. So we have 2 and ax. But since we have multiplied with 2, we also divide by 2. So this becomes b by 2. Now, since we have b by 2 as our b, we also add b square by 4. Now, since we have added b square by 4, we also subtract it. AC remains same. After this, we take out AC minus b square 4 to the right hand side. It becomes b square minus 4ac by 4. Now, left hand side remains ax plus b by 2 whole square. Now, after this, it is very easy that x will become minus b plus minus square root of b square minus 4ac by 2a. So this gives us two roots of the quadratic equation. Now we will see that indeed a quadratic equation has only two roots. So for that purpose, we assume that it has three roots, alpha, beta, and gamma. So these roots will satisfy the quadratic equation. Therefore, we can write a alpha square plus b alpha plus c is equal to 0. A beta square plus b beta plus c is equal to 0. And a gamma square plus b gamma plus c is equal to 0. Now we subtract first two. So c will get cancelled and we will have alpha minus beta into a into alpha plus beta plus b is equal to 0. Now because alpha minus beta is not equal, because we have different roots, right? If all the roots are same, what is the point? These are different roots, so alpha is not equal to beta. In that case, we have a into alpha plus beta plus b is equal to 0. That is this term equal to 0 because this is not equal to 0. Similarly, from first and third, we can obtain a alpha plus gamma plus b is equal to 0. Now we subtract these two, we get a alpha minus gamma is equal to 0. Now we don't have a is equal to 0 because it is a quadratic equation, therefore alpha must be equal to gamma. That means there is no way you can have three different roots. There is a bit of catch here. Okay, we have said alpha is not equal to beta. But in certain cases, a quadratic equation have same root. For example, any equation of the form x minus, say, a constant k, x minus k whole square is equal to 0. In that case, equation will have repeated roots, but there will be two repeated roots, not three. There will be only two repeated roots. That is, k is a repeated root. it comes twice, but we still do not say it has 3 roots, and we will see further why it is so. Now, from these values of alpha and beta, so these are the values of alpha and beta. You take plus sign once, you take minus sign once. From these two equations, you can clearly see alpha plus beta is minus b by a and alpha beta is c by a. Now we will discuss nature of the roots. So for this equation where a, b, c are real, when d is less than 0, now what is d? D is called discriminant. Discriminant is this term, b square minus 4ac. Okay. So when d is less than 0, both roots will be either imaginary or complex numbers. Now, they will be imaginary if b is equal to 0 and complex number if b is not equal to 0. And they are always conjugate of each other. Complex roots, when they always occur in conjugate pair. If d is equal to 0, both roots will be equal, as you can see. Because this plus minus term, when b square minus 4 is equal to 0, both roots will be minus b by 2a. And if d greater than 0, both roots will be equal and unequal. However, if d is not a perfect square, then the roots will be irrational. And they will also appear as a conjugate pair of irrational roots, just like complex numbers. Remember, complex roots and irrational roots always occur in conjugate pairs. Now, if d is a perfect square and a, b, c are rationals, then both the roots will be real and unequal. Now, we'll look at conjugate roots. So, we know that it comes as a conjugate pair, but let's see what we discuss. We assume that alpha plus I beta is the root of this equation, where a, b, c are real numbers. We substitute the root, we obtain, upon expansion, a alpha square minus a beta square plus b alpha plus c plus 2a alpha beta plus b beta into I is equal to 0. Now we separate out real and imaginary parts. We have a alpha square minus a beta square plus b alpha plus c is equal to 0. And we have 2a alpha beta plus b beta is equal to 0. Now we substitute alpha minus beta as the root of the equation. We get a alpha square minus ab, this should be to the power 2, plus b alpha plus c plus 2 alpha beta plus b beta is equal to 0. Now from this value, we see that this will be 0, and therefore this will also be 0. Thus, we see that if alpha plus beta satisfies equation, a quadratic equation, then alpha minus beta, which is the conjugate pair, will also satisfy the equation. And similarly, you can prove it for irrational roots also. Now we will look at quadratic equation and its graph. For the sake of argument, we rewrite this function as fx is equal to a into x plus b by 2a whole square minus 4ac minus b square by 4a square. This is equation 4.1. You might refer to it. So from this equation, we see that fx is greater than 0 or less than 0 for real values of x if and only if a is greater than 0 and less than 0. Why? The reason you ask me why, because when you will study functions and probably advance, you will see as x will grow in this equation, as x will become large, this term, which is squared, will dominate the entire expression. That means the value of this entire expression will be dependent on x, and therefore, say for example, large positive number or large negative number, in both the cases this will be a large positive number, and therefore the sign of equation will depend on sign of a. If a is greater than 0, the entire thing will remain positive. If a becomes less than 0, then it will become negative. That is the first condition. And the second condition is b square minus 4ac should be less than 0. The reason is if this is greater than 0, then this term will be less than 0, that is negative. But we don't want negative because for small values of x, this term will dominate. So, and we want it to be always positive or negative. Therefore, this should be always positive. That is, discriminant should be negative. So, that's how we prove that, and rest is just what I have written. Now we look at the graph. Now the graph when a greater than 0 will look like this. When discriminant less than 0 and a greater than 0, if you plot it, it will be like this. And this is x is equal to minus b by 2a. And at this point, the value of the quadratic equation will be minimum, and that minimum value will be 4ac minus b square by 4a. This you can very easily acquire by putting minus b by 2a for x. This will become 0 if you substitute x is equal to minus b by 2a. So we will have 4ac minus b square by 4 square only. So this is the distance of the vertex of the parabola. Parabola is always the plot of a quadratic equation. Now, you should always see that because our discriminant is less than 0, the roots will be complex. That is, it's complex plane. It is not xy real value plane. It is complex plane. And similarly, when a will be less than 0, the graph will be a mirror image across x-axis. So again, in the same case, our vertex will be minus b by 2a and 4ac minus b square by 4a. So in both the cases, the function fx is either positive or negative, always. Okay. Now we look at the sign of the quadratic equation. But what if it is greater than 0? That is b square minus 4ac greater than 0. Then we rewrite the entire thing as x plus b by 2a minus square root of b square minus 4ac by 2a whole square, and also whole square to x plus b by 2a. So we have the equation as a into x minus alpha into x minus beta. Okay. There should be a negative term here. This should be minus. In any case, once we have this, if discriminant is greater than 0, a is also greater than 0. If we plot the parabola, it will look something like this. Now, if this is the case, at some point, the parabola will intersect the x-axis. That is, y will be equal to 0 or fx will be equal to 0. Those are the points which you call root, right? Because when a square plus bx plus c is 0, we call those roots. So you observe when this parabola, the green curve, cuts x-axis, those are the position of two roots. And you see when it is less than alpha and beta both, that is this area, okay, the one above x-axis but towards left side is positive, that is fx is positive. And also when it is greater than both, it is again positive, but in between it is negative. So this is how it works out. From the plot you can see that. Now, so what is the least value of f? The least value of fx or quadratic equation will occur at vertex. Now vertex will occur at x is equal to minus b by 2a. So we make this 0. Once this is 0, the minimum value is this. So minimum value is 4ac minus b square by 4a. This is the minimum value. Now if a is less than 0, again, it will have the same nature. So this is the other plot for a less than 0. Now we look at position of roots. So first is condition for both roots to be more than a real number k. So in this case, we have alpha beta here, and this is fx, and this is, suppose this is our k. Okay. So in this case, if d is greater than 0 and a is greater than 0, then k should be less than minus b by 2a, and fk is equal to 0. So k must be less than this. Now, if we look at, and fk should also be greater than 0. Now we look at figure 4.6. k should be less than minus b by 2a, and fk should be less than 0 also. In that case, what we need is we will have that is roots will be greater than some real number k. Similarly, condition for k to lie between two roots. So if a is 0, discriminant is 0, fk is less than 0, that is one condition. K will lie between two roots. If a is less than 0, discriminant is greater than 0, then fk should be greater than 0. This you can figure out from this plot. In this case, a is less than 0, b square minus 4ac greater than 0. So between these two roots, the fk is greater than 0. Here, fk is less than 0. So from there, we figure out this. So from graph, we have that. Now, condition for exactly one root to lie between alpha and beta. So the two roots are k1, k2, where k1 is less than k2. Now, if a is greater than 0, then exactly one root will lie between the interval k1 and k2 if and only if fk1 is equal to 0 and fk2 less than 0. Also, same is true if this should be and only if fk1 less than 0 and fk2 greater than 0. Combining these two, we see that fk1, fk2 is always less than 0. So this condition is also true if a is less than 0. Condition for both root to lie between k1, k2, where k1 less than k2. So you can read this for yourself and you can figure out that how this will occur in the graph. Now, for this to have repeated root, the condition to repeated roots mean there will be only one root. So f alpha or fx we can write as a into x minus alpha whole square. So geometrically, if you want to see, the parabola should touch the x-axis. By touching, we will have only one point of contact. That is, the value of x will be minus b by 2a. That is the only possible route for the parabola in both the cases. It does not matter whether a is greater than 0 or a is less than 0. Alpha is equal to minus b by 2a is the only possible root which can repeat itself. There is no other value. Why I say so? Because if you expand this equation and try to find out the root, you will see how it works out. Okay? Because to have, if you can verify this from the original equation also. Where was that? Here. So it has two roots, but if b square minus 4ac becomes 0, remember our height was b square minus 4ac by 4a square. Okay, but if discriminant is 0, then this term vanishes and we are left with minus b by 2a. So that happens, the discriminant, what is discriminant? Discriminant is this guy. Okay, b square minus 4ac determines this height. This 4ac minus b square determines this height. But if this becomes 0, that is b square minus 4ac becomes 0, then the parabola will touch. Here also the parabola will touch, and thus we will have only one root, and that root will be minus b by 2a. So if you want to find out condition two quadratic equation to have one common, there is a typing mistake. This should be bold-faced. So suppose there are two quadratic equations, ax square plus bx plus c is equal to 0 and a dash x square b, not dash, a prime x square plus b prime x square plus c prime is equal to 0. We take a common root alpha. So the equations become a alpha square plus b alpha plus c is equal to 0 and a prime alpha square plus b prime alpha plus c prime is equal to 0. Now we solve these two equations, we get alpha square by bc prime minus b prime c is equal to alpha by a prime c plus, minus ac prime is equal to 1 by ab prime minus a prime d. So from this we get alpha square and alpha. Now you eliminate alpha and you are left with a prime c minus ac prime whole square is equal to bc prime minus b prime c into ab prime minus a prime d. So once this condition is satisfied, two quadratic equation will have one common root. Now, if you want to see this in picture, so this is one equation, this is another equation, two parabolas are intersecting once. So in that case, alpha will be a common root. The point of intersection will be a common root. Now, if they can have only one common root, if they touch each other, just like shown here, if they touch each other once, they will have one common root. In that case, the condition would be a by a prime is equal to b by b prime is equal to c by c prime if both roots are common. Okay. So the equations effectively will be identical. All right. Now we find general quadratic equation in x and y. So the general equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So the value in this case is given by minus 2hy plus g plus minus square root of 4hy plus g whole square minus 4a by square plus 2fy plus c by 2a. So we can say that x plus this 2 we cancel out. We can say that x plus hy plus g, and there should be an a also, ax plus hy plus so on, is equal to plus minus x square minus ab y square minus 2gx minus afy plus g square minus ac. Okay. So a we have taken to the right side and put it inside the square root. Okay. So this can be resolved into linear factors only if h square minus ab y square plus 2 gh minus fy plus g square minus ac is a perfect square and h square minus ab greater than 0. So this will be perfect square if its discriminant is 0. That is 4gh minus f whole square minus 4h square minus ab into g square minus ac is equal to 0. So the condition is abc plus 2fgh minus f square minus bg square minus ch square is equal to 0. So that is the condition for x to be there. Okay. So once this condition is satisfied, this equation will resolve into two linear factors. Now this is Vieta's relations which I have shown here. So if there is a polynomial like a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 and so on up to n minus 1 x plus n is equal to 0, then we can say that there are other conditions that coefficients belong to the set of complex numbers and a0 is not equal to 0. So as we have studied, this is an equation of degree n. So this is nothing but Vieta's relations which we have covered earlier. So similarly, based on Vieta relation, we have quadratic and biquadratic equations and the conditions are shown here. The product and sum of roots are shown here. So I think I'll stop here, and in the next video, we will resume from transformation of equations. An update is that I'm converting this PDF document. This is written using Contact. I'm transforming that to plain text using Lua text. So this entire document will change and there will be more corrections and better formatting and that kind of stuff. And those will be available at my website at ashtavakra.org. If you want, I can show you. Actually, there are other tabs open in my browser, so I won't show. You can go to www.ashtavakra.org and you can download this from there. So the PDF is available for download, and I don't remember how much I have done. I think if you look at answers, I have finished combinatorics solutions. I'm working on mathematical induction. So mathematical induction, once it is done, there are 5 more chapters. So you can say that more than half of the problems are solved, and I'll say solutions are like 60% done, 40% more to go, and then this book will be complete. And maybe after that, I will add more questions. So, in case you don't understand the spelling, this is my website, and you can go there. In the home page, there'll be a link in red along with the date. So whenever I upload, I change that date. You can download this PDF from there. And if you know Git or something, or you can write in comment box by pointing out the errors in the book, and I will try to correct it. Because you see, there are lots of typing mistakes, as you can see, I made when we were doing nature of fruits, right? Nature of fruits. So, for example, there are lots of typing mistakes. This reference is wrong, okay? And also at some place there is another mistake. This should be there. There is another mistake I had observed. Plus, this should, like, this is bold. So similarly, the other thing should have been bold here. This should have been bold. So there are lots of problems. At one place, the spelling of and was not correct. So these will be fixed as I find them. So there is nobody who reviews the book. I'm the only person doing it. So bear with me, and let me know in comments about errors in the book and how you found this video. I hope that you are finding this series of videos useful, and I'll see you in the next video. Thanks a lot for watching.